All right, hello Algebra 2. Welcome to 7.5, Properties of Logs. We're going to introduce some quick properties here of logarithms and how we're going to use those to solve problems. So we have the product property. Log base b of a times c can be split apart into the addition or the sum of two separate logs, log base b of a plus log base b of c. So I can take whatever two numbers are being multiplied here, and we'll split that up into individual ones and be able to add those two pieces together. Quotient property, similar to the product property, but instead the quotient property is going to subtract those two. Power property, this is a very big one. Power property, log base b of m to the p power. You can slide that p down in front, okay, and have it be p times log base b of m. That power of p slides down in front as a multiplier. And kind of a no-brainer one, the identity property, log base b of b equals 1. 1 is the power of b that gives you b. But that one kind of gets forgotten. Kids tend to forget that one or overlook that one and miss some silly problems because of it. All right. So let's do this practice splitting these up. Log base 2 of 15 equals log base 2 of blank plus log base 2 of blank. 15. What's going to multiply to 15? Okay, we could say 1 and 15. That's kind of a cheapie. Let's go with 3 times 5. Let's split 15 up as 3 times 5. So that would mean we could split this up into log base 2 of 3 plus log base 2 of 5. Okay, pretty easy stuff. Log base 2 of 2/3. I can split that up into a subtraction problem. Now, with the multiplication one, it doesn't really matter which one goes first. Subtraction one here, it does. The top goes first. Log base 2 of 2. Ooh, that's nice. We know what that is, right? That's going to be 1. And log base 2 of 3. Okay, log base 2 of 6 to the 5th power. All right, there's a couple things here we could do, but this is just trying to introduce to you the power property. We're going to slide that 5 down in front. Okay, we're going to have 5 times log base 2 of 6. Okay, we could split that 6 up into a 2 times 3 and separate that out even more. We're not going to do that yet. Okay, so that was just working on the properties, just the real basics of it. Okay, depending on how new of a calculator you have, you probably could use your calculator to get what some of these values are, but we're going to work on that in a later lesson. For now, we're just going to go with what the book or our notes or worksheet is going to tell us, and then we're going to have to kind of rearrange things or split things up so that it cooperates well with the given information. Okay, so it's going to tell us these couple values here. Log base 4 of 2 is 0.5. Okay, half or 0.5 is the power of 4 that equals 2. We should be able to kind of process that a little bit. This one might be a little weirder. Okay, log base 4 of 3 is 0.79. Okay, that's not going to be quite as exact. There's no nice clean power of 4 that gets me to 3. Log base 4 of 5 equals 1.16, and of course, log base 4 of 4 equals 1. So when the book is giving you these values, it's probably going to give you this one, this one, this one. It's not going to list this one out. It's going to expect you to know the identity property, that log base 4 of 4 equals 1. Okay? All right, so let's see what we're doing here. Log base 4 of 5 halves equals... Okay, we can use our quotient property to write this as a subtraction problem. Okay, this is going to be log base 4 of 5 minus log base 4 of 3 okay. So log base 4 of 5, I have that somewhere. That's 1.16 minus log base 4 of 3 is 0.79. And we can get a decimal approximation here of 0.66. Okay. Log base 4 of 16. I'll go with a different color here just so you don't get confused with like going straight down. I think dark green shows up. Okay, let's go with blue. Okay, 16. Well, I could go 2 times 8. I have the 2, but I don't have the 8. Okay, 16. I could go 4 and 4. Okay, we could do that. You could even go with the property power, or the power property of 4 squared. Bring the 2 down in front. We'll use that in the next one. Let's just go with 4 times 4. We're going to consider 16 as 4 times 4, just so we can work on a product property here. So that means we're going to have log base 4 of 4 plus log base 4 of 4, because it was multiplication, 4 times 4. So we separate it with a plus. Well, identity property, log base 4 of 4 is 1. 1 plus 1 equals 2. Okay, log base 4 of 27. Ooh, 27, that's not on here. That's not on here. There's no 27. Well, 27 would split apart to 9 times 3. There's a 3, but I don't have 9. Ooh, 9 splits apart to 3 times 3. So that'd be 3, 3, 3. This is 3 cubed. So let's take a look at that. This is going to be a power one. This is log base 4. Oops, let's switch over to pink. Log base 4 of 27 is 3 cubed. So we're reviewing that power property. This 3 can come down in front. 3 times log base 4 of 3. We have 3 times 0.79. And 3 times 0.79 is going to be about 2.37. Okay, we did a quotient property where I split them apart into subtraction and used these values here to subtract. Okay, 16 we said could have gone multiple ways. We chose to go with a product property, 4 times 4. So that was log base 4 of 4 plus log base 4 of 4. And that was 1 both times. 1 plus 1 is 2. Okay, don't expect it to be so nice and clean. You're probably going to have a decimal plus a decimal in your actual problems on the book. We did a power property, and sometimes it's not going to be straight up obvious and tell you 3 to the third. You're going to have to look at 27 and be like, oh man, there's no way to really make 27 out of that. And but we just talked about cubes not that long ago. 27 is 3 cubed. Then I can do the power property, and yep, now I do have log base 4 of 3, and that would work out nice. Okay, a little bit of a challenge problem here coming up with log base 4 of 30. Log base 4 of 30. Okay, so 30, my mind immediately goes to 5 times 6. And I see the log base 4 of 5, but I don't see 6. Well, 6 is not a perfect square or cube or anything like that I could look at maybe doing the power property. But guess what? 6 can get split up into 2 times 3. Okay, so this is log base 4 of 2 times 3 times 5. There's 3 things being multiplied. So we're going to split that up into 3 additions. Well, 2 additions, 3 parts. Log base 4 of 2 plus log base 4 of 3 plus log base 4 of 5. And now I have all 3 of those up here. That's 0.5. And this one's 0.79. And this one's 1.16. Okay, and if we add those 3 up, I'm seeing 2.45. Okay. I believe that should be enough to get you through your day 1. All right. If you are feeling a little ambitious, you can hang on. Maybe I'll do another sneak peek problem here for moving forward. That should get you through your day 1 assignment. Where are we at here? 11 minutes? We won't go too far here. We'll give you a sneak peek into what day 2 is going to be about. So day 2 is putting them back together and using that to solve some algebra. Okay, some algebra problems. So day 1, we are peeling things apart, pulling them apart with our log properties. Okay, this, we're going to kind of put them together. So log base 6 of x plus log base 6 of x minus 9 equals 2. All right, so we're putting things back together. If this is a plus, and these are both the same logs, what can I put them back together as a multiplication? Log base 6 of x times x minus 9 equals 2. So this is log base 6 of, let's distribute that x squared minus 9x. Okay, so log base 6 of x squared minus 9x equals 2. Now we're going to take our log, convert it to exponential, and solve. All right, you know Mr. Handke likes the 2 on the other side. 2 equals log base 6 of x squared minus 9x. 2 is the power of 6. That equals x squared minus 9x. So 2 is the power of 6. So we got 36. And we're going to get everything on the same side. Subtract that 36 over 36. No, that's not very good. And factor and solve. Okay, maybe do your magic x over here, what multiplies to negative 36 and adds to negative 9. How about a negative 12 and a positive 3? X minus 12, x plus 3, which means my answers are positive 12 and negative 3. Not done yet, got to double check. Okay, if I put 12 in here, this is log base 6 of 12 plus log base 6 of 12 minus 9 is 3. Okay, that would be okay. If I put the negative 3 in, negative 3 there, negative 12 here, and we know this part of a log can't be negative. Don't forget to test and check. So you're only going to go with x equals 12. All right, that's just a little sneak peek at what tomorrow's day 2 is going to be about. That front side of the page should cover you there for day 1. All right, thanks for watching, and good luck. Let me know what you got for questions tomorrow.